So, thank you for joining me. I'm Kelly, and I love beetles. And it says I have a strange relationship with them because I actually kill them for a living, unfortunately. And you may be thinking, well, why would you kill beetles? Some people kill insects because they are pests in the home. You may have killed a spider if you're afraid of spiders in the home, and that's perfectly understandable. About 1/3 of all our crops are lost to pest and disease. So we do want to kill pests in our crops. Unfortunately, that's not the reason I kill my beetles. Megan's actually safe because she's one of the good guys. She's one of our beneficial beetles that help to protect our crops from invertebrate pests. So carabid beetles, there's around 40,000 species in the world, around 350 species in the UK, and they are all pretty much scavengers of crop areas. There's around 30 species that live in farmland, and they control pests from slugs and snails, weevils, caterpillars, pretty much anything they come across. They're pretty voracious. So this brings me to, why do I kill them? And the first reason has to do with my lovely rain beetle black clock here. Like Megan, you can see that it has big jaws, and when we catch them in pitfall traps to see what they are doing in the environment, so a pitfall trap is a cup set in the ground, level with the soil surface. It's hard to gesture with a beetle in your hand, but beetles come along the surface of the ground and fall into a cup, and that's how we catch them to measure how many are in different farm habitats. But if they're in a cup together, they will eat each other. They're that voracious. They'll have a go at anything they come across. So we'd end up with one big fat beetle, and I wouldn't be able to know very much about them. So we do have to kill them by having a trapping fluid in that trap and killing the beetles as they come in. They die in a mixture of ethanol and water, so it's actually, you may argue that it's a good death. So that is the first reason. The second reason, this big-eyed beetle, it looks pretty big on the slide, look how beautiful it is, but they're actually only 4 millimeters in size. And to tell apart the different species of big-eyed beetles, we have to actually count these little eyebrow structures in between the eyes to tell between the beetles. So if you can imagine me getting one of those under my microscope while it's running around and trying to count its eyebrows, that would be quite difficult. So I do have to kill them to find out exactly what species it is. So, and the third reason is that we may want to find out what they've been eating. There are ways that we can find this out by putting out sentinel prey, but the most robust way that we have of telling what something is eaten is, unfortunately, to grind up the little beetle and find out what's in its gut contents and do a molecular analysis to see what it's actually been eating in the crop environments, and then we can tell exactly what pests they are controlling. And this particular beetle, the Sienna flat beetle, is a predator of cabbage stem flea beetle, which is a huge problem at the moment in oilseed rape. So we are looking into exactly how we can encourage more of these Sienna flat beetles in crops. And so the last reason, this hairy-templed thatcher is actually more of a aphid specialist. So if you know anything about roses in your garden, you'll find aphids on the roses in your garden. Well, these guys, they eat those aphids. But unfortunately, that means that they don't end up in my pitfall traps very often. But I'd still like to know where they are in farm landscapes. So this reminds me that I got this specimen that this picture is from the Rothamsted Insect Survey Archive. They have suction traps across the UK, and they sometimes catch these beetles in their traps, so I borrowed this beetle. Their insect archive is available for any researchers to come and access their collections and do science on it, really. We don't know what's going to happen in the future with beetle science. We don't know what amazing things people can do to find out more about beetles. So having these collections of they have to be dead to be collected. So having those collections to access is very important for future science as well. So that's the fourth reason that we might kill them. And on to the last slide. So this is actually a picture from my PhD doctoral thesis. And this says that I am thanking in my acknowledgements all the beetles that I killed. To make sure their sacrifice wasn't in vain, I want to make sure that I do science that means something from their deaths. So how many beetles did I kill throughout the 4 years of my doctoral study? If you just click, nearly 30,000 beetles. And I love them so much, but I killed so many of them. To date this year, in my doctoral studies, in my projects, I've killed around 5,000 beetles. So hopefully I've found out something useful from that. So what I have found out so far is that all those species that I talked around, about 30 in farmland, all respond slightly different to environmental conditions and actions that farmers take. So such measures as reduced tillage in fields. Different beetles react differently to that. Different beetles are more associated with field margins. Those are areas that we put in at the edges of fields in the more unproductive areas, so encourage beetles. But different species actually prefer those habitats more, and some species don't. One of the main predatory beetles actually isn't associated with field margins at all, more with undersowing in the crop environment, which introduces more diversity of structures and alternative prey right in the field centres. So that's what I've been able to tell on the first instance. So species of beetle matters. And all these beetles of different species have slightly different predation. As I went through the slides, I told you a little bit about the hairy-templed thatcher that ate aphids. So if each species responds slightly different to the environments of the farm, such as hedgerows, field margins, beetle banks, then that has a knock-on effect for what kind of predation we're seeing in the field. So potentially we could tailor our farm landscapes to encourage particular predatory species that we want in particular habitats for particular predation. So that's the second thing that I found out. The other thing was the way that we arrange these in the landscape actually matters as well. So I was able to model with my data from pitfall trapping the arrangement of the different beetles across a farm landscape and how that interacted with adjacent habitats. And I found that having an urban area next to your fields actually meant that there was less beetles in the field next to that. So maybe if we want field margins, we use them more of as a buffer area at the edge of fields. So the actual context and the way that we use the juxtaposition of habitats in the farm landscape does matter as well. So we can design it at a farm scale, not just a field scale, to encourage the beetles around the farm to where we need them. So that was the last thing. And the thing that I'm working on at the moment is working with farmers to do their own pitfall trapping so that they can work out and give me more data on different kind of habitats that we have in farms that I can't sample myself because it takes a lot of time to pitfall trap. So I'm getting farmers to go out there, put in pitfall traps themselves and use that hopefully as a way of adaptive management. So seeing what species they have on the farm, I will tell them about the different kind of predation they can expect from the beetles that they've trapped. And then seeing maybe we would want to put a ditch in or a hedge or something, more field margins in this area to encourage more specific species. And with these larger scale data sets, I can also see what those farmers are doing on their farms that has produced this particular assemblage of carabid beetles. And then I can recommend on a larger scale what we might want to do in other farms, what works well, what doesn't work well. So I'm aiming to get more and more data, killing more and more beetles, but in the end, we'll be saving more beetles and helping to produce more food sustainably. Thank you.
Well, thank you very much for that. It's an honour to be in the presence of a mass murderer this morning. Is there any questions for the beetle expert? Well, I was just interested to learn, Kelly, you saying about the urban fringe sometimes having a negative impact on beetle numbers in farmland. And if there's anyone passing who has a garden that is like that, or even a garden in the city, is there something they can be doing to make their own little patch more beetle friendly, would you say?
Yeah, there's lots of things that you can do to encourage beetles. It's thinking about what they need. So the beetles' needs are to feed, to breed, and to shelter. So in a farm landscape, we want to make sure there are alternative food resources to those crop pests, because crop pests aren't there all the time. And that's why field margins can be refuges for other invertebrates that aren't harmful to crops, but help keep the beetles there all year round. So in a kind of garden habitat, having wild areas of your garden can help to keep these beetles there over time. So that's feed. Breed. The carabid beetles breed in the soil. So having a good soil environment is also good. So an aerated soil, kind of lots of prey, lots of structure in that soil, different plants, different plant roots. Also a lack of disturbance. So I mentioned reduced tillage in farmland. That is one of the main factors that kind of reduces the amount of survivorship of the young. So reduced tillage is a major factor in farmland, but not so much in your garden. And to shelter, they actually overwinter. They hibernate, such as like other mammals. They hibernate when there's no prey around in cold conditions, and because they don't move around much in the cold. So having kind of banked areas, tussocky grasses and habitats that persist, such as hedgerows, will give them areas to shelter over winter and keep warm, so micro-habitats.
And do you think then that farmers of the future will be thinking about invertebrates in a planned way? They'll be regarding them as one of the tools in their armoury for crop production in the way that they may more commonly now be using sprays or other sort of control methods?
Yes, I really hope so. At Rothamsted, we're working towards ecological intensification. So that is trying to produce more with adding natural elements in, and trying to understand the way that these natural ecosystem services, as we call them, the goods that we get from ecosystems, we can actually get the good from that, not the bad. So not the pests, the actual benefits that we see from that. And that can be quite a hard process for farmers to go under from an intense angle. So trying to make sure that we understand these systems in order to put them into practice, because there will be a lag time in adopting those systems, because if you have been spraying a lot of pesticides and reducing the natural elements in the landscape for a few years, you're going to have less natural enemies to start with. It takes time to build up these kind of natural elements. So farmers need to know, they need to have assurance that this is going to work for the first instance. So us quantifying the effects will make sure that they can be sure that it will work, and how to put this in the best way, how to balance the elements of a natural system in an essentially unnatural system in a good way. So that's what our science is working towards.
And just finally then, are there any of your colleagues, are they mass murderers of any other species? Are you doing this work across all segments of the invertebrate world?
Yes, we have a moth mass murderer here, and then aphid mass murderer as well. So
Plenty of opportunities then for all types of researchers in the future.
yes.
Thank you very much for your presentation this morning.
Thank you.